Hey everybody, lesson 4, perms and coms. We're starting actually you could call it the second half of the unit, I guess. Um, well, maybe the second third of the unit because we still have binomial theorem. Anyways, we're looking at combinations today and kind of what those are. So part 1, this little example here, is a good way to kind of look at the difference. As part of a grade 12 English course, students are required to read the following 3 books in a 3-month period. Grapes of Wrath, The Wars, The Bean Trees. Okay, now we have 2 situations. We have Steve. So due to previous late returns, Steve is only allowed to sign out 1 English book from the school library per month. Lists all the different orders in which Steve could sign out the 3 books. Okay, so we could go Grapes of Wrath, Wars, and then Bean Trees. Or Grapes of Wrath, Bean Trees, War. Or we could do Wars first, Grapes of Wrath, Bean Trees, or Wars first, Bean Trees, Grapes of Wrath, or Bean Trees first, Grapes of Wrath, Wars, Beans, Wars, Grapes of Wrath. Okay, so it looks like we have 6 different ways that he could sign out those 3 books. Tariq is allowed to sign out all 3 books at the same time. How many different ways can he sign out all 3 books at the same time? So really, he's signing out all of them at once. There's only one way to do that, right? He just signs them all out. So for Steve, there's 6 ways, and for Tariq, there's 1 way. Okay, part A is an example of a permutation, right? Because the order in which he signed them out mattered. So we had different permutations. But part B is an example of a combination where the order wasn't important. We walk up, they scan them through. It didn't matter the order which they scanned them through because he's taking all 3 home. So what is a combination? A combination is a situation where the order of the selection is not important. Okay, so order does not matter. And you notice the word selection used, right? With permutations, we tended to use the word arrangement all the time. So that's kind of a hint as to if those words appear in the question as to what situation you have, perms or coms. Okay, let's go down, and it summarizes permutations and combinations below. So a permutation is an arrangement. Oh, I went way too far. Sorry about that. Okay, so permutation is an arrangement of elements in which the order of the arrangement is taken into account. So permutation, arrangement, order matters. Okay, order matters. Okay, combination is a selection in which the order does not matter. Okay, that's how I'll refer to it. All right, good. Let's look at the next page. Okay, so this is another example where you can kind of see how we lead into the formula for combinations. 5 students, we'll just call them A, B, C, D, and E. Notice the first letters. Okay, take part in a cross-country race to represent their school. First situation, the winner of the race wins 50, runner-up 25, third place $10. And the table below shows all the possible ways in which these 3 prizes could be awarded. So they've got ABC, ACB, yada yada, and all the different ways. Now, is this an example of permutations or combinations? So you got to think, does order matter? If Al wins first place, Byron wins second, and Colin wins third, is that any different than Al winning first, Colin winning second, and Brian third? Well, it might not matter to us, but it would matter to Al, Byron, and Colin because they get different amounts of money, right? So yes, this is a permutation because order does matter, especially to the people winning. Okay, how many ways are there to award 3 prizes? Okay, so if you count up all of these, now you know there's a fast way to do that, right? We have 1, 2, 3, 4, 5, 6 going this way, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going across. So 6 times 10 is going to be 60. Oh, sorry, that goes on the next second. Okay, 60 ways to win those 3 prizes. Okay, now let's look at the second situation. For participating, okay, so just for participating in the cross-country race, the school has been awarded 3 places at a running clinic. So the school coach decides to select 3 lucky students from the ones who took part in the cross-country race, those 5 students. And so we're using the same table, right? But the order, if he says Al, Byron, and Colin, you're going to the running clinic, it didn't matter whether he said Colin, Byron, or Al, right? So as a result, any scenario or permutation where you're using the same three people, we could eliminate all those other ones because they really would be the same, like same here, ABD, ADB. Okay, doesn't matter. They're all going to the running clinic, so order does not matter. Hence, this is a combination. Okay, how many ways are there to select the three students? Well, since order doesn't matter, we can get rid of all the situations where you're using the same three people, but just in a different order. So as a result, we're only going to have, if you look across here, there's 10 different ways to do that. So we had 60, now we're down to 10. So complete the following statement. The number of combinations is equal to the number of permutations, which we had as 60, divided by, well, we would have had to divide by 6 to get down to 10, right? Now 6, as you know, is the same thing as 3 factorial. So why was 3 factorial showing up? Notice we're using 3 people here. So really we're getting rid of all the situations where it's sort of like getting rid of repeats in a way, but getting rid of the situations where you rearrange them in order doesn't matter. So let's look at our formula and how that comes about on the next page. All right, so the n-choose-r formula comes from taking the permutations formula and dividing how many people you're selecting, because the order in which you select them doesn't matter. So it ends up being n factorial over n minus r factorial, and then another r factorial on the bottom. That's how the formula is different than the permutation formula. And yes, you can use the NCR button on your calculator. Now, there are 2 ways to write this NCR thing. You could write it like this, n choose r, or you can write it with the big brackets, n and then r below that. Okay, you're going to see both ways, so you need to be familiar with both ways. Okay, example 1. 3 students from a class of 10 are to be chosen to go on a school trip. How many ways can they be selected? Write the answer in factorial notation and evaluate, and then confirm the answer using your NCR button. Okay, here's a scoop. With combinations, and it doesn't matter the order in which these 3 students are selected because they're all going on the trip. With combinations, you do not have to do fundamental counting principle like we have been doing. It's just simply the NCR thing. So we have 10 students we're choosing from, and we're choosing 3. So this is how many we're choosing from, and this is how many we're choosing. How many we are choosing. Okay, now they first want us to evaluate that with the factorial notation. So using our NCR equals n factorial over n minus r factorial, we would write that as 10 factorial over 10 minus 3 factorial, and then 3 factorial. Okay, we could simplify that a bit. 10 factorial over 7 factorial, 3 factorial. We could expand the 10 factorial, 10 times 9 times 8 times 7. Hey, we've reached the one on the bottom. This is going back to lesson 2, you guys. And then 3 factorial we know is equal to 6. So let's just change that to a 6. Okay, because it's 3 times 2 times 1. Okay, 7 factorial disappears. Okay, I think I lost part of my screen there. And then we could reduce the 6 and the 9 if we want to avoid using the calculator as long as possible. So divide by 3, we get a 3. Divide by 3, we get a 2. Then the 2 could divide into the 8 4 times. So we would have 3 times 4, which is 12, times 10, which is 120. So didn't even use the calculator on that one. That's amazing. Okay, off to the calculator now. NCR, so in the calculator we're putting n choose 3. So let's grab that and figure out what that equals. Hopefully 120. Ta-da! N choose 3, or sorry, 10 choose 3 is 120 using the calculator. Good. All right. Ever wonder how many ways to win the 649 or what your chances are? Well, let's take a look at the next example. To win the lot of 649, a person must correctly select 6 numbers between 1 and 49. Jasper selected 6 numbers from the birth dates of his family, 3, 7, 9, 11, 20, 29. How many different selections of the numbers could he have made? Okay, well, Order doesn't matter in the 649. When the balls come out, they just, it doesn't matter what order they come out in. So we have 49 numbers to choose from, and we are choosing 6. Okay, so grab your calculator. Let's figure out what that equals. Okay, I'm going to show you a way to speed up these calculations. If you had 10 choose 3 on your screen just before this, and you want to put 49 choose 6, here's what you can do. Just go second enter, and it brings up what you just typed in. Or with the newer calculators, just scoop up and click on it. Okay, and then you can type in 49, and then you go over to the 3 and you type in a 6, and oh, I missed that, sorry. Let's go back. There we go. Hit enter. Oh my goodness, that's a big number. 139838116. 1398316. So, no, I missed one, didn't I? Okay, let's try this again. 139838816. Okay, that's what I'm missing. So in other words, approximately 14 million. You wouldn't write approximately on a real question, but for this situation, we're just talking about, let's talk about it now, right? So about 14 million different numbers. So if you only chose one number, your chances of winning would be 1 in 14 million, approximately. Okay, so do not write that as your final answer, though. All right, Athletic Council decides to form a subcommittee of 7 council members to look at how funds are raised to be spent on sports activities. There are a total of 15 council members, 9 males, 6 females. The subcommittee must consist of exactly 3 females. Okay, so let's look at how we would select these people. Order doesn't matter, they're all on the committee. It doesn't matter the order in which we choose them. So let's talk about choosing the females. We have 6 females to choose from. We don't want to use 15 because you're not guaranteed to get a female then when you choose 3 of them. So we want to narrow it down to choosing from only the females. So 6, and then we're choosing 3 of them. So 6 choose 3, whatever that equals. We'll do that in a second. Now we're going to choose the males. Okay, we want to make sure we choose just from males. So we want to narrow that down to 9 males. And we're choosing, well, let's see, how many are on the committee? 7. And we've chosen 3 females already. So that means there's 4 remaining people. Okay, so there'd be 4 of them. So 9 choose 4. And whatever that works out to be. Then the number of ways of selecting, say, the subcommittee. So we would have to have the 3 females and the 4 males. Okay, so again, you're asking yourself, would the word and or fit better there? So the 3 females was 6 choose 3. The word and in this unit, multiply, and then 4 males, 9 choose 4. Okay, and then that's going to work out to something. I guess we could actually work that out now. Let's grab the calculators and fill those in, so pause your video. Okay, so we should have gotten 2,520 different subcommittees. Okay, now part B, they're throwing a little bit of a twist at us. In how many ways can the subcommittee be selected if Bruce, the football coach, must be included? Okay, so that means we're really only selecting 6 people because Bruce is already on there. Okay, so we would then have 3 females, and I guess now only 3 males to choose from because Bruce was male. And then we can write 1 Bruce if you like, but there's only one way to select Bruce. Okay, so 3 females, we already knew that. That was the 6 choose 3. And, so multiply, number of ways to select 3 males. Okay, so not 9 choose 3 though, because Bruce was one of the males, so we're down to only 8 males to choose from, and we're choosing 3 of them. And then we're selecting Bruce, so there's one way to do that. Or you could write 1 choose 1 if you want. Okay, if we multiply those out, we should get 1,120. Okay, good job. Let's look at the next example. Okay, example number 4, we have a standard deck of 52 cards. That's assuming you know what a deck of cards look like, but they basically describe it for you here. So if you have never picked up a deck of cards, you can always read the instructions. Okay, 4 suits. Each suit has 13 cards. 2 suits are black, 2 are red, and face cards are the jacks, queens, and kings, and there's 4 of each of those. Okay, so poker is a card game played from a deck of 52. How many different 5-card poker hands? Well, if we have 52 cards to choose from and we're choosing 5 to make a poker hand, then that would be, wow, big number, 2,598,960. Okay, now we're running out of our 15 minutes, so I'll finish this example up in part 2 of lesson 4. See you then.